Heavy vehicle collisions often stem from a fundamental misunderstanding of inertia and momentum. Because a truck's mass is so great, its stopping distance is far longer than a car's, and because braking distance increases with the square of velocity, even moderate speed increases drastically heighten risk. Beyond physics, human factors play a role. Drivers often suffer from near-field focus, failing to scan hundreds of meters ahead, while the big vehicle bias leads to dangerous overconfidence in stopping power. When highway infrastructure lacks early warning systems, trailing trucks often become the primary force in chain reaction collisions. To mitigate these risks, defensive driving is essential. Drivers must adhere to the 3-second rule, actively scan beyond the vehicle directly in front, and use hazard lights to alert others to sudden traffic. Ultimately, safety relies on anticipating hazards well in advance rather than relying on late-stage braking. The footage captures a series of critical industrial incidents where workers operating in close proximity to active robotic arms were struck or caught by the machinery's high-speed movements. Due to the immense mechanical force involved, those affected were unable to free themselves, leading to severe physical injuries and an immediate, chaotic response from distressed co-workers who rushed to locate emergency shut-off switches. This sobering event underscores that safety is a matter of discipline rather than luck. To prevent such tragedies, strict adherence to safety perimeters is mandatory. Personnel must never enter an active work envelope unless the system is de-energized. Furthermore, proper fitted attire and PPE are essential to prevent snagging, while comprehensive training on the location of emergency stop buttons and rigorous daily maintenance of safety sensors are vital. Workplace safety remains a collective responsibility that must never be compromised by complacency. This incident was a physical explosion caused by the rapid release of stored energy from high-pressure, compressed air within a compromised tire structure. Root causes included structural failure due to material degradation, overinflation beyond safe operating limits, and improper bead seating, all of which led to a violent, instantaneous release of kinetic energy and shock waves. Such incidents highlight the severe risks associated with performing inflation on the floor without restraint systems. To prevent future occurrences, it is imperative to use high-strength safety inflation cages as the primary technical barrier. Furthermore, facilities must implement automatic pressure regulators, maintain regular equipment calibration, conduct rigorous per-task inspections for structural defects, and strictly enforce exclusion zones. Comprehensive technician training on pressure vessel physics is essential to ensure that all service operations prioritize safety and adhere to established industry standards. This incident underscores critical industrial risks, primarily stemming from insufficient segregation between personnel and heavy machinery. Key technical vulnerabilities include forklift blind spots exacerbated by large loads, the absence of dedicated pedestrian walkways, and a lack of active warning systems. These factors, combined with compromised situational awareness, create high-risk environments. To prevent such occurrences, facilities must enforce a safety buffer zone of at least 2-3 meters and implement comprehensive traffic management plans, including physical barriers, clear floor markings, and convex mirrors at intersections. Adopting advanced technology like 360-degree cameras, proximity sensors, and blue spot warning lights is essential. Furthermore, fostering a culture of defensive driving and walking where operators and pedestrians maintain constant vigilance and eye contact is vital for a safe, efficient, and professional workplace.